What if I told you one wrong switch could wipe out all your VLANs in seconds? Meet VTP, Cisco's powerful but dangerous protocol that can automate your VLAN management or destroy your entire network. In this video, I'll show you how to configure VTP safely, the shocking truth about revision numbers, and why transparent mode could save your job. Watch now before your next switch upgrade turns into a disaster.
In this course, we will see the configuration of the VTP protocol. On this topology, the 3 switches have been reset and the VLAN base file has been deleted. Once the switches have started well, on each 2, we launch the command show VTP status. In the release of this command, we see the revision numbers. Every time you add or delete a VLAN, it's that number that's incremented. Here it is at 0 on the 3 switches because no changes of VLAN took place. We see the operating mode of the VTP. Here they are all in server mode because it is the default mode, and the line VTP pruning, which allows you to remove unnecessary traffic on trunk links. For example, if a switch receives packages to VLANs, of which none of its interfaces are part of, then the packages will be deleted. This feature prevents the neighboring switch from sending packages that will be deleted anyway. Very useful to save bandwidth. We will now create a VLAN on switch A, VLAN 10, and called printer. We will now do a show VTP status on all the switches. We notice that the revision number was incremented from 1 on switch A and no changes on the B and C. This is because we have not configured a VTP domain. For this, we will execute the command on switch A, VTP domain, followed by the domain name we want to assign to it. Here it will be formation. As switch B and C also had no domain to set up, they will automatically take the formation domain. The domain sync would not have occurred if they already had a domain configured. That is, if their domains were not null. If we redo a show VTP status on switches B and C, this time we can see that the revision number has gone to 1, because they synchronized their lists of VLAN with the switch A. And if we make a show VLAN, we see that the VLAN 10 was created and is called printer. The VLAN 10 has been well learned by the VTP protocol. If all the switches are in VTP server mode, I can create VLANs on any of them, and they will be automatically propagated on the others. That is what we're going to do now. On the switch B, we create the VLAN 20, which will be called DRH, and on switch C, we create the VLAN 30 with the name direction. To check, we run the show VLAN command on all switches, and we can see that the synchronization has gone well. We will now look on the revision number with the command show VTP status. Each time a change takes place, the revision number is incremented by 1. That is why it's currently at 3. It went from 0 to 1 with the creation of VLAN 10, from 1 to 2 with that of VLAN 20, and 2 to 3 with VLAN 30. Now we're going to change switches B and C to customer mode by launching the customer mode VTP command. To check, we do a show VTP status, and we see that the operating mode is client. So we have the switch A in server mode, and the switches B and C run the client mode. To spice up the topology a little, I disconnected the cable between switch A and C. so there is no direct connection between them. Switch A will go through B if it wants to communicate with C. We will create another VLAN on switch A and see the effects on switches B and C. To do this, we make a VLAN 40, which we call marketing. And we check the behavior on switches B and C. Switch B learned VLAN 40 well from switch A, and C learned it through switch B. In customer mode, the switch syncs itself and transfers VTP information to others. On the other hand, it is impossible to create a VLAN in customer mode. For example, if you try to create the VLAN 50 on switch B, you get an error message from the CLI. All we must do is test the transparent mode. To do this, we will change the VTP mode of switch B to transparent by launching the command VTP mode transparent. We recreate another VLAN on switch A, which we will call this time support. By checking with a show VLAN on switch A, we can see that it considers the creation, but not on switch B, because it is in transparent mode and doesn't sync itself. On the other hand, it lets the VTP messages pass, which is why the switch C received the info by switch B. Note that it could only receive the info from switch B because we disconnected the link with switch A. If you create a VLAN on the switch B, which is in transparent mode, it will have no impact on the others. It won't announce its VLANs. It keeps them local, just for it. If we do a show running config on switch B, we can see the list of VLANs local. On the other hand, in client or server VTP mode, they are stored in the vlan.dat file of the flash memory.